session for webinar, artificial intelligence webinar by College of Computing, Informatics and Mathematics. Okay, so welcome to all of you. So we hope that we would receive more guests to join in this session. Okay, so yeah, forgot to ask you also. I hope that you can hear me. If yes, you can raise up your hands. Yeah, okay, I can see some of the hands, some of the participants. Yeah, good. Right, thank you. So, hopefully you can try. Okay, for those who have not installed the WEKA, so I hope that you could search in the Explorer. Okay, you just type, yeah, you just type WEKA installer, or you can follow, or you can find in Waikato University WEKA. So, invite you. So, this WEKA. Okay, you can just type in the video and then WEKA. Downloads. Right. Oops. WEKA. Yeah, see why I go to this link. Okay, find the one, the words download, and then click over here, and you can see the version of installer for WEKA, right? So may use the stable version and click here. Yeah, click here. Right, so you can have the installer and run it in your computer. Okay. Right. So currently we have 21 participants. Right. So I will begin the presentation first. Yeah. And then we will go to the demonstration, and you might follow what you can follow me while I'm doing the demonstration of using WEKA. Hopefully uh, the line is stable, yeah, and also same with your site as well, yeah, the line is stable, and we can perform the online and also using the WEKA synchronously. All right. So before we begin, can you just chat, put your location, yeah, in the chat. Where are you from? I can see some of the names is from UITM. So hopefully we also have some of the participants from other university as well. And this program is actually been promoted by the internalization. Yeah, in our college we have one internalization um, uh, and the coordinator is here. Yeah, and so I welcome Dr. Azima.
Thank you,
Dr.
Dr.
Azima.
Sophie.
Yeah. Okay, I can see someone from Novi Susanti. Novi Susanti, where are you from? Novi Susanti, where are you from? You can type or you can on your microphone. Yeah, Novi Susanti. Okay, and some of my inbound students over here, Bambang, Miftah, yeah, and also Putri and also Rahmat. Yeah, these students are in Medan currently, Kisaran to be specific, Kisaran Asahan. Okay, the rest I would anybody? Amy, where are you from, Amy? Amy Kudratul, where are you from? Mm. Oh, yeah, Amy also from Indonesia. Yeah, welcome, Amy. Where's your other friends? In progress to join, Amy? Hmm. I hope they are coming. Okay. Right. So for today, I've been given this opportunity to share some of my uh, uh, knowledge about clustering. So yeah, as you see in the screen, I've shared you uh, one of the materials that we are going to use today. Yeah. So this is the slides. Okay, and I will share you the respective link for you to view the slides and also some of also the link to the exercise. You might want to try it later on, yeah, after we finish the session. Okay. So yes, again, I would like to brief you. Okay, first I'm going to start with the presentation first, yeah, because this is actually the background and also the related, yeah, knowledge about clustering first, and then after that we are going to use WEKA, which is one of available tool, yeah. And to begin here, yeah, to begin here, I would like to introduce. Wait, okay. Hopefully you can see my screen, right? Can you see the screen? Okay. Right, hopefully it's clear, yeah. So I would like to introduce our college, so formerly known as Faculty Science, Computer and Mathematics, ataupun in English, Faculty of Computer Science and Computer and Mathematical Sciences. So we are in University Technology Mara, which is one of the public university in Malaysia. So we can consider ourselves as the largest university in Malaysia with several campuses, yeah, available and can be visited, yeah, when you are in Malaysia, in West Malaysia and also East Malaysia. So there are 12 campuses and 6 satellite campuses. And I'm here is in the main campus, Shah Alam, Selangor, yeah, Selangor. So if we see that uh, in Selangor itself, there is several campuses actually. However, here in Shah Alam is actually considered as the main campus. Okay, and we have more than lots of programs, estimated around 500 academic programs, yeah, sorry, and to be counted of the number of students will be estimated around 170 all over the Malaysia. Okay, so here this is the building of our originally been known as faculty. Now our is actually known as college. Yeah, college. Yeah, so we have three main what we call field, yeah, knowledge, yeah, knowledge area, which is computing sciences, yeah, and also we have mathematics and together with the informatics. Okay, so one of the field is actually in Puncak Alam. Okay, so computer science and mathematics is in Shah Alam. So a little bit about myself here. Have been here in for 20 years. Okay, I've been taught some of the subject in bachelor's and also master subjects. Okay, for bachelor, I started teaching data mining since 2019. Yeah, 2019. No, sorry, 2009, yeah, so back around 14 years, yeah. So this subject is being what we call introduced in bachelor students, yeah, bachelor programs. That was intelligent system students. Okay, and I also have some experience in intelligent system development, yeah, DSS, that is decision support system. For master student, I have taught applied data mining, yeah, for master students, and seminars for data science students, and also final project for data science students. Okay, I have embed some of the research in text analytics, machine learning. Okay, a little bit about data analytics, yeah, big data analytics. Definitely currently this is buzzword, big data analytics, because data is most likely every type of data can be considered as big data. And some of the unstructured data, not only in the form of text, but also in the form of images. Yeah, so some of the project been done for the object detection and also of image classification. Okay, so for this session, yeah, we are expecting that we are given a job here, yeah, a special task here to share about the data analytics itself. Okay, and in my session, I'm going to introduce the clustering methods, which is considered one of the unsupervised methods. Okay, and then we are going to apply it in WEKA. So my topic will be relates to the analytics. Yeah. So as for introduction, this is something that you might currently been hearing. Yeah, it's talk about data analytics. It's talk about big data analytics. So big data analytics definitely is due to the source, yeah, the source of data. So now you can see the data comes to you every day, every second, yeah. When you holding your computers, when you holding your handphones, especially, yeah. Uh, uh, by looking at one particular apps, yeah, while looking at one particular apps, there will be lots of information provided to you. If you open your computer, firstly, might be you have the weather, right? So like myself, I will check, okay, what is the weather for prediction about the weather. So it will be changed hourly, yeah. So actually I can see what is what is the temperature for 9 a.m. and then later on at 10 a.m. and then later on at 11 a.m. I can see the change of that because definitely our computer it's been fed with the information directly from the internet, yeah, by through our apps. And then these apps, okay, how many apps do you have in the handphone? Have you counted the number of apps inside your handphone? How many apps? How many apps? Have you counted it? Mm. So I keep on installing. I keep on installing every day. Every day I cross over some of the new apps, I will install it. There is some of the behavior of the user, yeah, like my kids keep on installing a new games inside the tab. So there is one of the sources of data that you gather actually, yeah, some of the data that you install in the app is coming from the wearable, yeah, wearable devices, yeah, not only internet but also wearable devices. So technically if you look at your apps, yeah, in feeding, in sensing the data from the environment is actually producing the big data. Okay, so if we look at the characteristic of the big data, we can see some of the elements or some of the criteria, yeah, that can be considered as big data. Probably you want, I'm not going to go to too detail about it, but I want to introduce, yeah. Yes, some of it is related to the volume. I think the volume could be clearly been seen, yeah, clearly been seen. If you look at the mobile apps in the context of images, right? So technically, in the first version of handphone being used, your image will be in kilobytes. So now your handphone can store up to megabytes, and not only a single number, but three digits, so 200 something, and then 300 megabytes and so forth. So the volume is keep on increasing. And then variety, yes, not only in the form of image. Do you have video, you have YouTube and so forth? So the voice coming in the form, the voice also producing some of other types of data. So this is known as the variety. And then okay, veracity, yeah, we have value, okay, velocity, and so on money. If you talk about these, is actually, if you look at the literatures, some of them will introduce 7 V's, some of them will introduce 10 V's as the element. So most importantly, you would know, or you would see this volume, variety, yeah, velocity. Velocity, we talk about the time, the how fast it change over the time. So not only using mobile apps, sometimes you look at the CCTV, so it's capturing data every seconds, yeah. So the change, the human behavior in, like, if you monitoring the human behavior in the airport, and also human behavior in park, will be different velocity. Okay, so when we have this data can be analyzed, yeah, data can be observed. Okay, and from this observation, okay, this is actually something that we can relate to the analytics, right? So analytics is referring to the science of using and analyzing data, okay, to build models for better decisions. Yep. Technically, sometimes this one can be, I mean, you have done it throughout the years, yeah, like, you know, at certain point you able to make decision because you have observed that particular situation or that experience, yeah. So in the context of why we call it as a data science, yeah, or related to the analytics, because it has a certain process. It has a certain practices. Okay, so in that context, that's why big analytics will be related to the data science. And before this, we only heard about computer science. Yeah, we know that as applied science, we know there is a lot of domain and data data actually can be categorized part of the science, yeah, science, fundamental of science knowledge. Okay, so after you have observed the data, and then you can understand about the data, and you can represent some kind of decision making process. Yeah, you know how to make decision based on certain scenario. That is actually one particular modeling context. And definitely, if we look at the organization, it will help the organization to understand the needs of the organization, as well as the user context. Means that in the user context, we might know what is the market trends, and we might know what is the customer preferences. So it help in extracting the business insight, so that we can uh, make use it, yeah, for better decision making. So this is actually what we call as the big data analytics, started from the source of data, and then applying some of the relevant steps in modeling process, yeah. And to go specific, what is actually the analytics, yeah, what are the process or what are the steps, yeah. So as I mentioned just now, we have lots of source of data, and this kind of data can be in the form of very structured form. Okay, so this is targeted. Maybe you have a targeted database to be um, linked or to be connected. So the targeted database already in the form of proper row and column. Okay, and somehow we could have a semi-structured. Yes, semi-structured, it has a specific columns, but in the inside it, the value will be some differences. Yeah, some of differences in the form of numeric. Some of the values in the cell could be in the numbers or strings. So it create variability here. Okay, and definitely unstructured, where you can see a different form of data. I mean, if you look at the posting, some of the posting consists of 20 words, some of the posting consists of 100 words. So it shows unstructured. The produce or the feeder of the data would do any would expecting us to extract what is the most important value inside the data. So this is unstructured data. Okay, so this is where the source of data comes in. And if you remember, of the main tasks in terms of dealing with data could be the cleaning of the data. Yeah, so data pre-processing is part of the data pre-processing, where our data have to be prepared and so forth. So here, if you list out the tasks, yeah, for data preparation, processing or preparation, involve the cleaning process, where you want to remove some noise, remove some kind of missing values and so forth. Integration, where the data is coming from the different source. Transformation, so you want to make sure your data in the form in a standard form. Okay, so some of the data given by different databases is represented female as 1, some of the data represented female as F. Yeah, some of the data is represented female as perempuan. So there is the difference. Yeah, there is the difference in information provided in different database. So we have to look at the transformation as well. So this will be creating consistency. So why it must be consistent? Because we are dealing with the machine learning algorithms. So this algorithm, yeah, even though it's a artificial intelligence approach, definitely the designer and the developer needs to give to provide, yeah, some structured, yeah, some process data, so that it some what the form, yeah, a proper form of data, so that the algorithm will works well. Okay, okay, I forgot about data reduction. Yeah, we deal with the big data, but some of the elements is nonsense, or some of the elements will be repeated many times. So we have to reduce some of the repetition. Okay, that is one scenario. There's a lot of things to be discussed about that data reduction as well. in data mining or in machine learning, like feature selection and so forth. So that one will not be covered over here, but later on, if you want to look at the data reduction, also important task in machine learning, especially in the data mining, because some it will be related to the efficiency and also the effectiveness of running the modeling process. Okay, so we are going to look at some of the algorithms available, and at the end, it will have in terms of generating the insightful actionable insights. Yeah. So as a brief, yeah, as an introduction of the data analytics, so we have three main, so type of analytics. We started with the descriptive analytics, what happened, and then the main task under the descriptive analytics will be describe, summarize, or find similarity. So we will understand the real situation and take the opportunity to make use the results, in segmenting, in identifying something hidden or something never been found, right? So in predictive would be related to what are the trends. So we are going to use this approach in predictive analysis to classify the variables into certain categories. So at the end, this model or this type of analytics can be used for the future or estimate the outcome. Okay, so the target for here is law about something what you want to do in the future. Okay, and lastly would be to do, okay, to the prescriptive. So not only giving you specific steps, what is what will be happening in the future, but also the steps to achieve that particular situation. So if you look at the detail of descriptive analytics, most of it will involve in what we call exploratory data analytics, but we can use unsupervised methods under descriptive analytics, definitely, to understand about the data. Okay, and prescriptive would be dealing with, or similarly is being known as supervised methods. Okay, and prescriptive can be considered as supervised and also unsupervised methods being used together. Okay, so these are the algorithms for data mining. So as you see, this is supervised, this is unsupervised. So we are going to look at unsupervised methods, but to compare between supervised and unsupervised. Anybody know about that? What is the difference between supervised, unsupervised? What you can describe or what you can tell about supervised and unsupervised? Amy, do you know what's the difference about supervised and unsupervised? Do you know about supervised or unsupervised? Not sure? Okay. How about the rest? Maybe the rest can help. What is the supervised and unsupervised? Okay, good. Miftah tried to answer here. So supervised, where your data set have labels. All right, good. Meanwhile, unsupervised, the other way around, meaning your data has not any do not have any labels. Okay, that will be a clear difference, between supervised and unsupervised. Okay, And then if we try to imagine, yeah, so supervised meaning that the algorithm will learn, yeah, with a teacher. So because the historical data have specific information about how it been classified, how the category is been divided. Okay. Meanwhile, for unsupervised, it's involved a lot of exploratory. Yeah. So you need to try several options or several alternatives to see the potential of how you're going to divide your data. So definitely, if we heard this one, supervised could be straightforward because you can have a specific number of labels. Meanwhile, for unsupervised, yeah, you have to try several options. And at the end, okay, at the end, you don't know how to, you might have a problem to evaluate because for the supervised, it is very clear, okay, if it has been predicted as actual, meaning that that data is correctly predicted, okay, and then if the data or if the records is predicted versus or not same with the actual, it is considered incorrect. So at the end, we can calculate how many correct and then we can get the accuracy. So that methods for supervised is clear. Though in unsupervised methods, okay, you have to try the options, meaning to say you have to try, okay, you have to try, for example, can we divide the data into two clusters? Okay, we run and we look at the outcome. And then for the next option, we try to set the cluster into 3, set the cluster into 4. And then we run and then we have to observe. Yeah, we have to observe and definitely there is some value that can be picked up over here to differentiate between one output to another output. Okay, we will discuss it later on. Okay, so this is the modeling tools available. Okay, smaller, if you're smaller data set, definitely you can use the Excel. But if you have a bigger data set, online, real time, definitely you need to use some powerful dashboard. Okay, Tableau, Fusionex. Yeah, in Malaysia you have Fusionex. Okay, or you can use a Power BI. A Power BI can be associated to the Microsoft, definitely. These are among of commercial visualization tools. Definitely you have to know some of the pricing as well. And another tools that can be used here, yeah, these are among of the statistical tools with advanced, some of the basic machine learning algorithms and also advanced algorithm. Okay, so not only WEKA, we have others like Orange data mining. So Orange data mining normally can be found in the Anaconda platform as well. Yeah, if you are installing Python Anaconda, yeah, so you can see this Orange package, yeah, in being installed as well. You can use R, okay, or you can solely use the Python language, yeah. So inside the Python language, you have Scikit, you have TensorFlow, you have that Keras, yeah, many what we call many package available in the Pythons, yeah. And we can use RapidMiner if you want, and also Canimate, yeah. So this RapidMiner, Canimate, Orange, and WEKA has advantage in terms of because the data, I mean the tools provide some of the GUI interface so that you can extract, yeah. I mean you can make use of the functions, yeah, or you can use the icons to drag and drop. So yeah, I'm going to start with the what is cluster analysis. Before that, is there any questions from the participants? Any questions? Okay, no questions. Right? While you listening to me, yeah, if you want to install the WEKA, yeah, install the WEKA, you can go to the browser. Okay, you can go to the browser. Okay, and then just type WEKA download. Okay, and then you can find with you can find what we call official lah. I would say official WEKA website from the Waikato University, and then you can click download, get the stable version. Okay, so that one is WEKA. That one WEKA. In the meantime, while you're listening to my explanation, okay, you can find the WEKA. You can find the WEKA in the browser installer using your browser, and you can install it, right? Okay, so uh, I will go to the cluster a little bit, approach here. So cluster is actually one of unsupervised learning methods, which if you look at, they have no specific predefined classes. So this example given here, you have a set of data, or you have a set of objects given here. There are 10 objects over here, and how many variables? How many variables that we have in this particular records? How many variables? Refund, and then marital status, and also taxable income. So how many variables? We have three variables. Okay, so three variables from this data set, and we want to know which object is actually related to each other. So we want to find the similarity. So whether object 1 similar to object 2, object 3 more similar to object 4, 5 or so forth. We don't know. So we need to find. We need to find. We need to find. If object 1 and object 2 is similar to each other, then it can be merged and create as a cluster, one cluster. Okay. So we will compare. Actually, in cluster analysis involve pairwise comparison. Lots of pairwise comparison. If you look at cluster 1 will be object 1 will compare each of the object. Same object 2 will be compared to each of the object as well. And same goes to object 3 will be compared to all these objects. So as that particular description, okay, you might see that how cluster will, because it can help in terms of finding similarity. So the application will be, for example, to find the similar energy, use customer profiles. So we are using the customer profiles, like gender, location, and then house, type of a house, okay, and then we have a number of devices in the house, so we can see what is the energy use. And then abnormalities, behavior for the computer security. So we can look at how, for example, you look at files of the user accessing like mail server and so forth, whether the frequency of this customer accessing this mail server is can be monitored every time, or sometimes we can see that they use some kind of bot to email to everybody in the contact list and so forth. So this is actually something can be abnormal. So we can define this is the source of the mail. It's coming from the mailbots. And then visualization, definitely we want to look at the data distribution, and then we can use it for the pre-processing steps. For example, just now I showed you one of the data pre-processing is to look at the data reduction and cleaning data. So this cluster analysis can be used for data cleaning and also data reduction. Okay, right. So this is another view of how we can actually divide or segment the data into 3 different clusters. So each of the cluster consists of object. Actually, the distance between the object has been minimized. Okay, so we target that this distance, yeah, can be minimized. So it can be formed a cluster. And cluster means that the difference of one cluster to the cluster can be maximized. So this is the target of cluster analysis. Okay. And when we talk about similarity, and then just now we talk about distance, so actually we make use what we call as the distance similarity function, yeah, to to identify the objects, yeah, to identify the object that belongs to the same cluster, yeah, or do not have any similarity within the cluster. Like you have seen here, okay, definitely this is not similar to each other, so it should be excluded, excluded. Okay, and then we know that data set might consist of several types of attributes. So different type of values, yeah, or different type of data will influence, yeah, the use of distance function. So in our example over here, sorry, um we are going to look at methods of clustering, which is specifically to partitional clustering. So what is partitional clustering is actually referring to the methods, the clustering methods, where your data will be divided, yeah, into partition, and each of the partition is separately, clearly separated, exclusive, exclusive mutual. So among the algorithms that will be popular for the partitional clustering would be k-means and k-mod methods. Yeah. So apart of partitional clustering, we have hierarchical clustering. Okay, so hierarchical slightly different. If you see the outcome of the hierarchical clustering, it will producing some kind of nested clusters. Yeah, so as you see, this is nested cluster, meaning to say this is the smaller cluster, and then you have a bigger cluster. At the end, everybody is in the same big cluster. Actually, that can be represented into the dendrogram. So this is the starting point where the point 2 together the point 3, okay, with a specific distance. Okay, and this cluster can be merged the point 4 with a specific distance, and this all cluster can be merged with the point 1 with a specific distance. So this is creating hierarchical tree. So we can see the potential of data where you want to see, okay, the heritage of the heritage of behavior or heritage of physical appearance, yeah, small from a small animals, yeah, like cats, yeah. So the distance between cats will be, I mean, cats actually a cat species can actually, you have cat, and then you can have tiger, and then you can have lion, and many more. So those are actually one specific cats, but cat is a smaller size, and then is if you look at the biggest size like cheetah, and then the largest size of cats will be lion, and so forth. Sorry, I'm not that particular, but you can see the largest species of cats will be yeah. If I remember, I went to the zoo, and then I remember, okay, when I see lion, oh, it's a very very big compared to the cheetah. Okay, so hierarchical would be the best to use to discovery the hierarchy of the species, for example. Okay, though we are going to focus on the k-means here. So in k-means, it's actually giving you an example by using attributes. So this example, if your data given or been visualized in the graph form or x and y, so this is x, okay, this is y, and x and y is presenting as the attribute 1 and attribute 2. Okay, so and then inside it you have sample 1, sample 2, sample 3, and sample 4. So in the naked eyes, you definitely can know. Yeah, you can know. In naked eyes, you can see this is one cluster because it is quite near to each other. And this is another cluster, isn't it? Do you agree? Okay, do you agree with my statement? Do you agree with my statement? Okay, humans have a ability to see it, yeah, but computers do not have the ability to see it. So, computer have to calculate. Computer needs to look at how far one object, yeah, from another object. So it need to calculate the distance. That is known as what dissimilarity distance. Okay, in this context, because your data is numeric, we are going to use what we call Euclidean distance, right? So the generic Euclidean distance is equal to the object 1 and object 2, and this is the difference of value of variables 1, okay, uh, for object 1 and object 2, okay, and then squared plus the difference of variable, second variable between object 1 and object 2, okay, plus other variables as well. In this context, we have only two variables, right? Okay, in this context, we have only two variables, so we can translate, okay, the distance by this formula, Euclidean distance formula, and this is will be the way how to count it. Okay, so as you see, we look at, we look at the difference between x1 and x2, so we can count the difference of 3 minus 1 and 5 minus 2, and then the summation, the summation of squared, and then it will be square root, the summation will be square root, and then you will get 3.61. Okay, you can try later on to get the rest. Okay, this is I have shared the PDF file, in the link given in the chat over here. Okay, so you can have a look at it, these slides, right? So you can count for this. You can count for this. Yeah. So at the end, computer will make use. Yeah. Computer will make use the distance found over here to merge the objects, right? So this is the fundamental of finding distance of object inside the clusters algorithm, clustering algorithm. And if you look at steps, the pseudocode of K-means algorithm, so here we will start with partitioning the object into K. So like I said just now, in clustering, comparatively to the supervised, in clustering is involved exploratory. So meaning to say you have to define what is the number of cluster that you want to extract from the data. So let's say here you want to, then we represent the parameter with K. So here come with the K value. K means algorithm. So when you have decided the K value, so we are going to partition the object into the K non-empty subsets. Okay, so from that first iteration definitely is initialization, where the seed points are considered as the centroid, meaning to say from the original the original K, K objects, K, I mean, number of, number of K, number of cluster that you want to divide, you have to initialize the number of centroid. If you say that you want to have two cluster, then you have to define or initialize two centroids. Okay, so after that, we need to calculate what is the distance each object inside, inside the data set, to the centroid. If the object is nearer to one particular centroid, then it will be assigned for that particular cluster. Okay, and it will be repeated, meaning that after we know the assignment of each of the object, and then we will restart to the step 2, sorry, step 2. And then recalculate a new centroids. Okay, reassign the object to the new centroid. All right. And then after finish assigning all the object to the cluster, recalculate a new centroid. Okay, it will be repeated until the assignment, until the object stay in the same cluster after several iteration. Okay, so as you see, this is an example given to you of k equal to 3. Okay, we want to assign the data. Okay, we want to assign the data to 3 clusters. So this is the initial value of centroid. Okay, so we assign, we calculate each of the objects, whether it's nearer to centroid, and then as you see, this is the updated centroid. Okay, after the assignment, this is the updated centroid after the assignment, and then at the end, okay, the centroid, okay, will be remain, will be remain in the iteration 5. The centroid will be remain, okay, and the clusters, the object in the cluster will be also remain. Okay, oh sorry, the other one. Okay, so after iteration 5 and iteration 6, there is no changes, of the centroids and also the objects. Then we will stop the iteration. Okay. All right. So any questions? Any questions?
No question,
Any
Doctor.
questions? No, Bamba? Okay, good. How about the rest who are from Telcom or others, maybe? Okay. No question, I guess. So, okay. So now we are going to look at mana ni saya punya cursor. Let me find my cursor. Okay. So understanding, after you understand about k-means, then we are going to look at the WEKA. Yeah. So I hope that you really understand the use of, the algorithms before we see the output of k-means by using the WEKA. Okay. All right. So now we are going to look at WEKA. Okay, maybe before we go to the WEKA, I will request you to just type in the chat whether you have the WEKA or not. Okay. If not, please make sure that you have installed it. Especially those who are not from my class lah. Okay. Can you just type WEKA done? Okay, Adli have typed something. How about the rest? Okay, Ishad also done. Okay, Faris, Aiman done. Okay. I think most from my side already done. I'm waiting for Amy, Dr. Angelina. How are you? I'm expecting somewhere like Hadi. I'm not sure Hadi from Telkom. Hairi, Hadi, do you have the WEKA in your computer or you just want to listen? Just type. I just want to confirm. Yeah, okay. Right. So, hopefully you also install it lah, yeah, it's okay. So I just proceed, yeah. So, we are going to use WEKA, which is actually has been used in university, started being used in the University of Waikato, and then I also um, um, make use this particular tools, yeah, in my class, yeah, and some of the research with the students as well. So I continue starting from 2009 until now, still use WEKA. There is a lot of algorithm available in the WEKA. So it's an open source, yeah, it's an open source. So there are many, it's like, it's a Java based, yeah, but it can be integrated with the Python, it can be integrated with the your own database as well, okay, and you can manipulate the Java environment in the Python as well, okay. And it has a very simple GUI compared to the Kenime, or compared to the what we call Python Orange, yeah. So and then uh, it has a basic interface, yeah, where you can what we call familiarize the function before we go to the canvas. So something different in WEKA actually for that particular module, or that particular availability. Yeah. So let me share the screen for, because WEKA has a what we call two, yeah, two interface. Show you it simultaneously. Okay, so this is the interface of WEKA. I hope that you can see it. Yeah. Yeah, so using the interface of WEKA, you can access some of the other application. So we have Explorer, Experimenter, and then Knowledge Flow, Workbench, and Simply. So this Explorer, this is what I'm talking about, where you can make use the menu, yeah, in a straightforward manner, yeah. And then if you are considered doing a lot of testing, a lot of measures, observation of measures, then you can go for the experimenter. Okay, and if you want, you actually already advanced in understanding each of the functions in the Explorer, you can go for the knowledge flow. Or you think that I want to have an interface, drag and drop, and so forth, you can directly go straight to the knowledge flow. Okay, workbench and simply also another functions, where simply you can call the Java command. Okay, so I will click to the Explorer. Okay, so this would you can have preprocess, classify a common or basic installation. Yeah, you can see preprocess, classify, cluster, associate. Yeah, and then select attributes and visualize, I guess. Yeah. Though I have extended some of the functionality of WEKA by installing the package of Visual 3D and also apa, 4J inference. This one is actually for CNN, yeah, CNN. And then here for the first interface, yeah, to make sure um the menu is able for you to use it, then you can click to the open file and find the data first. Okay, so we are going to get the data and you need to go to the C command prompt, sorry, command C directory where you can find it in the program files. And here under the directory of program files, you can have WEKA and you can see data. Okay, so we are going to use iris data. Okay, so iris data considered as one of the benchmark, yeah, benchmark data set. Okay, so this benchmark data set has been used in a lot of machine learning experiments. Okay, so what is iris data set? It's actually flower. Okay, as you see, this is iris setosa, this is iris versicolor, this is iris virginica. As I said to you, if you are a human being, you look at the image, you can see, this is different between setosa, versicolor, and virginica. But if you provide the data to the computers, definitely computers do not have eye. So we have to pick up some measures from the data. So the representation of sample length, sample width, petal length, petal width is being captured, yeah, from the group of images, yeah, so ataupun group of I would say the flower. Okay, so you can click to the edit, then you can see the detail information of sepal length, sepal width, petal length, and petal width in the data set. Okay, so I forgot also before I proceed, yeah, so this part, okay, as an introduction of data when that can be accepted by WEKA, it can accept originally in a ARFF format. Yeah, so attribute relation 5 format. This is the first version of data for WEKA, but currently WEKA also can receive or can open any comma delimiter, yeah, a comma separator files, yeah, and it could be in the numeric and nominal. So what's the difference between numeric and nominal? Numeric is numbers, nominal is actually a value, yeah, specific value like hair color, yeah, red, white, yeah, black, okay, and then you can have also other um sometimes I mean I'm not going to give any complex information, but I give you the straightforward information like you have weather and then you can label it as weather hot, yeah, sunny, and so forth. Okay, or you want to have weather data that can be represented in numeric like temperature, humidity, and also like for example wind, yeah, wind velocity, yeah, and string can be accepted, and normally string will be again it will be need to be processed, yeah, because string can be represented as at the end, yeah, can be need to be processed, yeah, especially when we deal with the text mining, when we deal with the text classification or text clustering. So from string data, then we have to perform some kind of pre-processing, tokenization, until tokenization, and it's been represented in the TF-IDF in the numeric form, then we can apply the WEKA processes. Okay. So data can be gathered from the Kaggle or UCI. So the one that we see here in WEKA data is actually can be found in the UCI. Yeah? Iris data can be found in the UCI and also the Kaggle. I think some in the Kaggle, the number of samples will be more. Yeah. So when we click to visualize all, again, I repeat, when from the first interface, this is the description about attributes. So there are five attributes given here. Yeah, five attributes. And this is the description of each of the attribute. When you scroll down, it will be changed. On the right hand side will be changed. Okay, petal length will be changed, petal width will be changed, and also class will be changed. Okay, so if you want to view all the attributes, you can click to the visualize all. Okay, so until to the S10, yeah, up to the S10. Is there any problem or any questions? Okay, any question from those in Telcom or any other university or any other participants? Any questions? No? Okay, so clear? Okay, so this is what you can view as the data as you see. It shows some kind of formation between and do you know why in Sepelang it has what blue color, red color, and turquoise color? Do you know about that? Maybe my students know lah. Dia tahu kan? How about the rest? Do you know why we have here in the Sepelang we have red, we have blue, turquoise? Hmm. Why? So give you answers. So it's reflect to this one. Okay, like there is a Sepelang. Okay, this is Sepelang distribution of the data, and then each of the records is belong to the Aristotasa. Some of the records is belong to versicolor. Some of the records is belong to the WEKA. So it's actually the data, yeah, the these colors is actually representing the class level. This is the class level. Okay, and this is for Sepelang, and what is the class level for the different instances or different records, right? Okay, and then after this, okay, we want to apply the clustering. Okay, as you see, the data have label. Okay, remember just now I mentioned to you. Okay, I mentioned to you. Normally we apply clustering without the label, okay? Ataupun we are given the data, without the label. So we mimic the situation over here. So we want to remove the class label, okay? So you can click remove. Now, purely your data will be in the form numeric and we do not have any specific class label, okay? So as you see, here you will be showing plain information about the data, the distribution, okay, the distribution, and then all the the distribution of the sepal petal width, petal length, and petal width. Okay, right. So after you have seen here, I just want to introduce you with some of available in the processing. Yeah, so if your data is iris data is already clean, I mean there is a lot of what we call how you want to know whether it's a clean or not. One of the indicators will be whether you have the description about missing data. So if you browse over here for sepal length, sepal width, petal length, petal width, there are no missing data provided value here. There is meaning to say it's a clean data. Okay, so if, for example, you found data with missing value, then you can apply pre-processed functions over here. Can be found under unsupervised. Okay, you can click attribute and then you can see here replace. Replace. So where is it? Yeah, so replace missing value. Okay, you can click here. Okay, you can see this is a very small arrow. So when you click the small arrow, it will apa kita panggil expand, ya, expand the selection of functions lah, ya. Okay, so just now I want to replace missing value, then you can choose replace missing value. Okay, so there are more. Yeah, they are more like at noise. Yeah, you want to test some of the algorithm, robustness of algorithm towards noise. So you can include noise to your data and then you run classification or clustering, for example. Okay, you can also apply discretize. So discretize means one of the transformation, meaning to say originally your data in the form of numeric here, yeah, numeric form. Then you want to divide it into bins, yeah, number of labels, yeah, number of labels. Like I want to have small, medium, large, like that. So I can divide it into 3 bins. Okay, in this particular exercise, I won't do this one. Okay, but later on, if you want to do that, definitely you can apply it. So what is the implication when you apply bin or putting into the proper level? Sometimes it give advantage when you understand, if you understand the representation in the form of rules. For example, you apply decision through tree, or you applying for the associate, definitely your data need to be transformed into the nominal. Okay, so at the end the rules will be clearly okay. If your sample length is wide or small, then is what, yeah, types of species, yeah. Okay, so this will be discretized. Okay, you can have more. Okay, and normalize, yeah, to change the value into certain range. Okay, so as you see, this range started from 4.3 and then 7.9. If you want to make it standard, you can transform it into a scale of 0 to 1 or positive to negative. I mean, um, uh, 0 to 2, depends, depend on the situation. Okay, and there is a lot lah. There is a lot. You want to sort based on and then for the instances, yeah, that one is for pre-processing under attribute. If you look at the instances, okay, you can apply some of the functions to randomize, yeah, to randomize the seed value, yeah, if you need. And then you can remove duplicates. Yeah, here you can resample. So resample could be a very popular methods if you want to apply reduction, data reduction. For example, you want to see what is actually happening in certain size of data, whether the pattern of accuracy is maintaining or the pattern of accuracy is decreasing when you resample it. So yeah, that one can be done over here. Yeah. Okay, so this is a pre-processing, meaning I just want, again, I repeat this, what I'm trying to share with you, some of the functionalities or some of the filter in WEKA that we can use to process your data. Actually, not necessary purely you want to do all the classification using WEKA. Sometimes you need tools. Okay, you'll find a very hard for you to do the replacement in the Excel, then you can apply in the WEKA. Okay, but it requires to change into the CSV format. Okay. All right, so this will be the class, the first steps. Okay, I will go straight to the cluster. Okay, I didn't do anything because that one I don't apply anything here. Yeah, I just remove one of the attribute. Again, I repeat, I just remove one of the attribute which is originally a class level. So we want to mimic a process for supervised which we do not have any class level. Okay. So here, if you look at the cluster, okay, so you can see several options. Yeah, several options. I also give you some of thought about what is hierarchical cluster just now. Okay, but here we are going to focus on the simple k-means. If you notice one while I'm hovering the mouse, yeah, so you can see some description about the algorithms. Okay, so there is a lot of description provided actually for each the algorithm. So in case you're unclear, or you want to know the source of the paper, yeah, this will be a some of the example. This will be some of the information that you can extract from WEKA. Okay, here, after you choose simple k-means, like I say, what is k-mean just now? K-means meaning to say you have to determine what is the partition number, partition, how many partition, how many cluster that you want to have, for your data set. Okay, so here, how you want to put it, how you want to put it, that assignment. Okay, so over here you just can see the cluster mode. Okay, we are going to click on the maintain in the training set, and don't remember to click store cluster for visualization. Okay, and this part that you are going to click in the text box, so when you click, you will get the properties of the algorithm. Again, if you're not sure what is the algorithm about, you can just click to the more. Me also do not remember all the in the WEKA. There is a lot. I'm not sure. 1,000 plus 100,000 plus, lots of algorithms here. Though the platform is very easier for us because it's already there. Try and error many available algorithm for not only cluster but classification and so forth. So this is the scheme about this k-means. Okay, and who proposed k-means? Okay, what is seed? Okay, as you see, seed can be seen here. Okay, seed can be seen here. Standard deviation. Okay, and the number of execution slots, right? Canopy and so forth. Okay, I just want to highlight two main properties here in this exercise. Yang paling penting, the most important properties that we are going to use today will be here, the distance function. Okay, and also initialization here is random, but you can actually apply others. Okay, but it's okay. Now we apply random. Maximum iteration, leave it as 500. Okay, and number of cluster. This is where we want to apply. Where we want to apply when we want to change some of number of clusters here, so that we can see the changes of the output. Okay, and this is the seed points, meaning to say out of 150, just now your data consists of 150 records. Out of 150 records, how many points will be pulled as the seed? So it will be chosen as the centroid. So just leave it like this. Okay, so we are going to try with 2 cluster and click OK. Okay, and then you can click start. All right, so here, meaning to say, this is the output of WEKA. Okay, so run information, WEKA, a scheme that been used for the selection, selected task, which is k-means, and then number instances, number of attribute. Okay, and then as you see, okay, initialize starting points, okay, or select is actually random. We assigned 2 clusters just now, right? We have assigned it to for the algorithm to find 2 clusters. So as you see, 2 centroid will be initialized. 2 centroid will be initialized. So cluster 0 and cluster 1, these are the centroid. What is 6.1? What is this? 6.1, 2.9, ni apa ni? What is it? Do you know what is this? 6.1 and this is 6.2, 2.9, 4.3, 1.3. The plot. Okay. Any other questions? Any other answers? Okay, so data plot, okay. Values of attributes. Thank you, Lokman Hakim. So Lokman Hakim give the better answer. Okay, if you revert to your data just now, we have how many attributes? Four. Yeah, four, which is sepal length, sepal width, petal length, and petal width. Okay, so when we look at the cluster, okay, so this is actually the centroid being chosen in cluster 0 with attribute of just now lah, sepal length. This is sepal length. Okay, this is sepal length. Okay, and this is petal width. This is petal width, and then this petal length, and this is the petal width. Okay, so centroid for 0, this one. Okay, and centroid for cluster 1 is this. Okay, so in WEKA, the first Java lah, especially the first indicators, the first apa nama point is started with 0. Okay, so 0. This is the first cluster. This is second cluster. Okay, so when you look at the results in WEKA, okay, it will depends on the number of variables. If it has 10 number of variables, then you will have 10 values over here, yeah, which reflect, yeah, to the value of variables for the centroid, yeah, for the centroid. Okay, so this is and then this is centroid 2, yeah. Okay, so and after certain iteration, as you see, this is will be the division of or the partition, yeah, the partition. Kalau kita tengok data, sorry, if I refer to what is K means, is K means is about the partitioning. So the partition of data divide to 2 partition. So this is the full data set, okay, with the mean value for each variable. So in cluster 0, yeah, these are the mean value for each variable. Okay, so full data consists of 150.0. What is this? Ini apa pula? What is this? Full data consists of 150 instances. Yeah, and this one, or the first cluster, consists of 100 instances, and the average value for sepal length is 6.262, and then sepal width 2.872, petal length, and then petal width. Yeah, and this is the second cluster with 50 instances. So as you see, given more information about the time taken to develop the model, and this is the clusters. Yeah, this is the cluster, reflect the information that you see over here. Okay, meaning to say 67% belong in the cluster 0 and 33% belongs to the cluster 1. Okay, so any question for this part? Okay, tak ada. So, because just now we have stored cluster for visualization, we can go to the result over here. Okay, and then right hand click and go to visualize cluster assignment. I repeat, okay, just now we go, you can go to the results produced over here, right hand click and visualize cluster assignment. Okay, now this is the instance number, right? Okay, so it's the number in the X, yeah, in the X. And then this is the clusters, yeah, this is the cluster that you see in the color, in the red color as the cluster number 2, and then blue color as the cluster number 1, yeah. Okay, in this particular visualization, you can only see one variable at one time. Okay, this is scatter plot. This is scatter plot. So you can see only variable at one time. Okay, right. You can change, for example, in your naked eye, you can see, okay, there is actually one cluster, two cluster, three cluster. If you base on the sepal length, how about the rest? This is sample width. Yeah. This is petal length. Okay, petal length is very obvious. Okay, actually, you have 2 or 3 cluster. Right? So if you look at the petal width, same goes the petal width. Whether it's actually 2 or 3 cluster. Okay, meaning to say in the visualization, it helps us to verify. Yeah, it helps us to verify the data, whether it should be belongs to the 2 cluster. Now we try to do another number of cluster. Okay, so we change it to 3 clusters and then click OK and run again. Start, you click start. Now, can you compare the scatter plot from 2 cluster with the 3 clusters? Okay. Okay, some kita panggil overlap, some overlap instances in cluster 1 and cluster 1 and cluster 3 over here. Some overlap information also within cluster 1 and cluster 0 and cluster 1, red and blue. Okay, if you look at the petal length, same petal length, some overlapping, but it's a better. It's a better visualization when you use 3 cluster. Yeah, and then if you look at petal width, yeah, some overlap, but it's a better description when we assign it as a 3 cluster. Okay, so that's why if you look at the application of clustering, it's actually in describing the data, summarizing the data. Yeah, so back to the data analytics just now. Okay, over here you can see, okay, descriptive. Yeah, descriptive analytics is actually to look at what happening. Okay, so what happening can be described based on each of variables that you have. Okay, which produce influence to the division or segmentation of the data. Okay, you look at the real situation, real situation based on each of the variables. Okay, and indirectly, it can help you to summarize the data. Okay, so the engine behind it actually finding similarity. So that is how clustering tackle to understand, tackle to the complex stuff in analyzing what is behind the situation. Okay, let me go back to this one. Yeah, okay. Right. Okay, so this is what is the outcome of K-means or partitional clustering. We are going to divide data into specific number of cluster. Okay, and we want to see actually your data will be best represented by how many cluster. Okay, and if you look at another example over here, another main purpose of clustering, this one, for pre-processing or for the visualization. Okay, but I'm so sorry because I'm not sure here, in WEKA, you able to see the scatter plot for 2 dimension like this one. Okay, and we can put it into 3 dimension. Wait, let me try. I will not try for clustering. So yeah, so for 3 dimension, saya tarik. Let me try to. Can you see the image? Can you see the scatter plot? But it's quite limited view lah. Let me try to sample it. Let me simplify the sample to 50%. Okay. So now I'm projecting the display, yeah, based on 3 variable. Okay. Let me change to the color. Because the color, oh, okay. I'm sorry. So it doesn't store the cluster itself, but it's only based on the variable itself, the value of sepal length, sepal width, petal width, and petal length. Unfortunately, I cannot find it. If we can repeat the same way how the scatter plot is, where we can represent the colors by cluster lah, yeah. So the limitation is over here. Yeah, the limitation is over here. Okay, so that one is one part. Okay, you can proceed with further number of clusters over here to test whether, yeah, you can get a better clustering or not. Yeah. Another thing that I want to share is that, okay, let me try here. Yeah. So you can save the results. Yeah. What do you mean by saving the results over here? Okay, let me try. Yeah. Here, and then I just put it here. Okay. Iris cluster. Okay. And then put it as CSV lah, yeah. CSV, yeah. Okay, save. Let me save it. My WEKA. Okay, save. Okay, let me bring back to the let me go back to the Explorer. Okay. Just now I save it in the, oops, alamak, ada problem pula. Oops, ini I am able to do that, but supposedly when I save it, yeah, save the buff. Oh, not the sub. Okay. Now I remember. Wait, it should not like that. Okay, so okay, let me check it, huh? So you should go to the scatter plot, eh? You should go to the scatter plot, eh? Not this one. Back. Okay, this one. Close it. Okay, close it. Close it. Okay, I back here. Where is my tree plotting? Tree plotting. This one. Okay. This one, eh? Let me share. Let me save it. Save. Let me try to save it. Let me do in ARFF lah, better kan? Cluster, iris. Okay, save. So when I go back to Explorer just now, this is one. Okay, so what I'm trying to show just now, actually, after you get the clusters, yeah, and then you know the best representation of cluster, and then what you can do is that you can store, you can store the finding, just now. After I compared, okay, cluster 2 and cluster 1, this is cluster 2, okay, and then this is cluster 1. I say that, oh, cluster 2 is not that good because some of the variables should be represented as 3 cluster. So I choose cluster 3 rather than cluster 2. Then I save the data, okay, into your partition or into your data inside your computer, and I can retrieve the data again. Okay, when I retrieve the data, as you see, there is cluster. Okay, there is cluster being shown. Okay, so the cluster shown here and with the variable just now. Okay, so instances number, okay, katakanlah for example, I just remove the class. So this is actually the cluster produced. Yeah, so if you are an advanced learner, ataupun advanced user, okay, probably you want to test whether this cluster is best to be represented for the data. Then after you have the cluster, you can run here, okay, apply another algorithm like decision tree to see the accuracy, how the clusters that been produced just now is best or not best to divide the data. So that is how you evaluate. That is how you evaluate the clusters that you have produced in k-means, okay, and you evaluate it based on the classification. But not only that way, you want to test the cluster or the outcome of the cluster. Let me reshare here. Okay, let me go back to the slide. Okay, not only that way, you can perform the evaluation of the cluster. Okay, you might want, for example, okay, perform an evaluation here. Perform an evaluation using the given parameter, given the measures being found in the WEKA. Okay, like this one. Okay, here, as you see, there is a sum of square errors. Okay, sum of square errors. Yeah, so you have to repeating. Yeah, you have to repeat. For example, from 2, 3, 4, 5, and 6, and then you capture the value, and then look at which will be producing smallest error. Yes, some square error. Okay, so the one easy way to reduce some square error is to increase. Okay, and by observing, smaller k can lower the number of some square error rather than a per clustering with higher k. So let's say here I have plotted some of the experiment starting from 2 cluster, 3 cluster, 4 cluster, 5th cluster, and 6th cluster, and then I capture this value. Okay, I capturing this value and plot it. Okay, plot it in the graph. So this is the graph. Okay, look at the orange color. Okay, look at the orange color. Okay, so there is one practice that you can refer to. This is where you can see the effect of different cluster numbers. Okay, so where it started to become more stable, more balanced for the sum square error, so that is becoming the point that we pick up the best number of cluster. In this case, okay, the starting point is where the cluster is 3. So it's also been proved just now when we visualize the data, there is 3 cluster is much more better. Yeah. Okay, and yeah, so this is what we call, or I didn't put the term. Yeah, you can refer to these references as well. Yeah, talking about the evaluation, the term is actually referring to the elbow effect. This is known as elbow effect. Yeah, this is elbow effect. Yeah. Okay. Any questions? Is it okay? Okay, I have shown this part. You can see it just now. Okay. Uh, just want to finish with the limitation of the k-means. Yeah. There is some limitation of k-means due to the initialization and randomized states. Yeah. So sometimes there is encouragement in terms of do not perform much randomization. Okay, and maybe there is certain way of choosing. Yeah, limit the. Uh, you have to observe the data first, and then identifying the best centroid. Yeah, for that particular process. Okay, so that will be um, scope, yeah, scope to um, uh, some kind of process, yeah, some kind of process before we apply the k-means itself, yeah. And as a deployment of the analytics, yeah, related to the data analytics, the deployment of analytics can be done after we have validated the output. Okay, so just now we look at this more. Yeah, we do not have a look at any case study. Okay, data preparation pun not much. Yeah, we go directly to this analysis modeling. But in the business world, yeah, so you have to identify the relevant data definitely. Okay, we have to clean the data before we go to the modeling and validation. It needs a lot of steps, and at the end it will be something to do to the visualization and presentation, yeah, before we deploy the methods in the organization. Okay, this is known as CRIPS DM. Okay, some of the reference that you can or you might want to use this, you refer to this, the papers that I have done in the k-means. One is for the image data, just replicating a little bit something that relevant to the iris data, and we done based on the tropical plant, yeah, tropical or herbal plant that we found in the Taman Negara, Kuala Tahan, Pahang, yeah, of reservation forest in Malaysia. So we capture some of the herbs, peacock fern, and then kacik Fatima, tapak Sulaiman, misai, adam, okay, mempisang, and padan. So we look at this clustering, yeah, to look at the patterns of these different plants image. Okay, so Dr. Angelina or any other academics from Indonesia, yeah, if you are interested to do something in plants in Indonesia as well, yeah, we might want to try, yeah, to perform an experiment using cluster, yeah, yeah, we might collaborate, yeah, to deal with that as well. Okay. And we have here, also here is text mining, which we are using textual data being captured in the social media. So based on the clustering algorithms, which is actually not k-means, but you are using LDA, and we divide and we look at what the interrelated terms, yeah, that actually can be extract from the feedbacks. Okay, so we look at the urban center, urban area, and then we apply the LDA, and then look at the topics, yeah, the topics and related terms, yeah, and we apply the coherence score definitely to represent the data, coherence score to measure the representation of the data. And as you see, there are 3 clusters as been shown in the results. Okay. All right. So before I go to this one, I just want to brief a little bit about what we have. We have in the college. We have AI group. We have analytics group, cybersecurity groups, and also informatics groups. We have I'm going to I'm going to leave you with this activity. Dr. Azima have remind me, don't forget to give them take-home exercise. So this is the take-home exercise. So I hope that you can try it. Okay, it's actually doing the same exercise, which is iris data set. Okay, but it's just that I want you to maintain the variable class. Okay, because it helps you to understand actually why why the number of cluster is divided is best represented by the number that you choose later on. Why is 3 is more what we call significant to the data set. Okay. And I ask you also in the exercise to try on the hierarchical. So you can try also in the hierarchical to see the difference between k-means and also hierarchical. And lastly, the exercise will be asking you to test on the accuracy. Okay, so there are 3 main components in the exercise. You can try and submit it. And I will pass this exercise also to apa nama to the record of internationalization department. Okay, right. So that's all from my side. Thank you very much. And if you have questions, please ask me. And Hazlami have pasted some of the attendance form, exercise after class, and also the ni. Okay, for attendance form is actually for the international students, yeah. Hazlami. Dr. Azima, our students also can should fill the form or not, yeah, Dr. Azima?
Yes, all students, all
Oh,
participants need to fill in.
Okay. So Hazlami, I correct my words here. Okay, you have to fill it in the form, fill the form as well. Yeah. So all participants, okay, please fill the form as well for the record of internalization. Okay. So this is the what we call, you can have steps of downloading, especially those from Telcom. And then this is the slide given here and the QR code to go to the exercise. Yeah. Okay. Tak ada question, tak ada pertanyaan? Enggak ada pertanyaan?
So far tak ada.
Tak ada. Okay. Right. Kalau tidak ada, I think we have to record the apa nama? The participant. Okay. The participant lah maksudnya to record our gambar lah. So let us take picture. So hopefully you can on your camera. Hazlami tolong ambil gambar boleh? Hazlami, can you take the picture for us? Tapi tak ramai lagi yang on ni. Asfarudin, muka tak nampak lah Asfarudin. Nampak seat awak je. Okay. Ibu Novi ada, Dr. Angelina. Okay, boleh ambil gambar lah Hazlami, please. Okay. Nanti you paste Cakap 1, 2, 3 lah dulu.
Tak apa doktor, saya ambil kan.
Okay, okay.
1, 2, 3.
Okay.
Okay dah.
Okay. Thank you, Asfardin. Alright. Okay, thank you to all of you. Anything you can ask. Drop email ke. Drop WhatsApp pun ke boleh. Ya. So thank you very much to all participants here from other university as well. Thank you, Dr. Azima, and thank you, Dr. Angelina and Bu Novi, for joining this class.